This is our first radical introduction concept. I wrote all the perfect squares because it's going to be helpful in a minute. So now I already showed you that if you have a number that's on this list, like 36, the square root of 36 is 6. 1, 2, 3, 4, 5, 6. 6 times 6 is 36. That's why radical 36 is 6. 6 squared makes this number. Now, what if there was a number out there? Let's say there was a 2 out there. Now, when you free the 36 from the jail, remember, I like to call the radical a jail. So radical 36 comes out as 6. He comes out of jail. You free him. But the 2 is out there waiting. Remember, this 2 cannot go in there. The 2 is not going to go into jail. No one goes into jail willingly. All right. So the 2 is waiting for his friend to come out of the jail. And then they get together and hang out. So if there's any number in the front, this is a product. And you would multiply them together. So that was the stuff before. Now, what happens when I give you radical 12? 12 is not on this list of numbers. All right. There's a reason I wrote that property there. What my goal is, I want to write 12 as a product of smaller numbers where one of them comes from that list. Now, I can write 12 as 6 times 2. The problem is that 6 is not on this list and 2 is not on this list. Neither one of these numbers is going to come out of the radical. They're not going to come out of the jail. So that's not the pair that I want to choose. I have to make sure I choose a number up there. And you have to pick a perfect square when you write this as a product of smaller numbers. So I'm hoping that you realize you have to pick 4 times 3. 4 times 3 is 12. Now, there's a reason I'm writing it underneath like this. I wrote 12 as a product of smaller numbers where one of them is on the list of perfect squares. Now I'm going to use the property where I take this and I split it up into 2. Radical 4 is 2. He comes out of jail. He's a perfect square. He gets released from the radical. The 3 does not. He is stuck there. He is never going to come out. This 2 cannot go in there. He is not going back in jail. He just got out. Why the hell would he go back in there? So this is how you break down a radical. All right, this is called simplifying a radical. Now I'm going to do another one. All right, so I erased the first one. We're going to do a second one of simplifying. So again, I want to use this property. I want to take 20 and I want to write it as a product of 2 numbers. Now, again, you say, oh, 10 and 2, 10 times 2 is 20. But the problem is 10 and 2 are not perfect squares. They're not on this list. So this is not a pair I want to pick. So I go through and look, 20 is not divisible by 16. It's not divisible by 9. You try to divide. 20 is divisible by 4. So I have to keep the 3 in front of the jail. So I'm going to split 20 up as 4 times 5. You have to write the 4 first. I mean, you don't have to, but this is the guy that I'm going to pull out of jail. So I should write him first. You don't have to. This 3 has to stay out there. He is waiting for his friend to come out of jail, and then they're going to hang out. So the 3 stays there. I wrote my product. Now I'm going to use the property to split it up. And yes, I want to see these steps. This is your work. I want to see that you wrote the product. You split it up. Now, right, there's the property. Multiplied, split them up. Radical 4 comes out. So make sure you understand, this is 3 times radical 4 times radical 5. So the radical 4 comes out of jail as a 2. The radical 5, he's stuck. He don't come out. He's got a life sentence. Now I do 3 times 2, which is 6. And that's it. 6 doesn't go into jail. 5 doesn't come out of the jail. This is the simplified form of the radical. This is how you break a radical down into smaller numbers. All right, you use that property. I'm done. All right, so the next concept is going to be adding and subtracting radicals. Now, in the class notes, it says really specifically, you can only add and subtract them if they have the same radical part. It's similar to this concept. You can't add these together because they have different letters. They would both have to have the same letter in order for you to combine them. And you would add the numbers in front and you would keep the letter the same. This is exactly what you're going to do here. You're going to keep the radical part the same. They have to be the same. So you keep the radical part and then you just subtract the numbers in front. You do 8, take away 6. Really friggin' easy. I mean, this is a joke. Add or subtract the numbers. If this was a plus, you would have put a 14 there. All right, so add or subtract the numbers in the front, keep the radical part the same. Now, what happens when they're different? When they're different, you can't add them. You cannot add radical 3 and radical 2. But it's radical 5. It doesn't work that way. You cannot add the numbers inside the radical, all right? You would not be able to do this. These are different creatures, right? These can't be combined. What are you going to write? 13xy? This doesn't combine. So when they have different numbers inside the radical, they don't go together. All right. Now, adding and subtracting. Now, I just told you, you can't add them unless they have the same number inside. So you could be saying the same thing. 48 and 3 are not the same number. However, I can write 48 with a 3. There is a reason they gave you this 3. This number didn't just come from, nowhere. It wasn't made up. They gave you that number because it is possible to write 48 as something times 3. Now, let's say you can't spot. Like most people, when they do 48, will do this. They'll take 48, they'll write it with 4 and 12. And then radical 4 comes out of jail, and they get there. The problem is that 12 breaks down more. 12 breaks down with 4 and 3 again. And you can keep going. This is too much work. If you get a number that continues to break down like 12, then you know that the pair you picked wasn't large enough. So look, here's how to do it. I need something times 3 that makes 48. 4 times 3 is 12. That's not big enough. 9 times 3 is 27. That's not big enough. 25 times 3, 50, 75. Too big. So let's do 16. 16 and 16 is 32. Do 16 again, right? That's times 2. 48. Son of a bitch. Yay. It's 16. 16 times 3 is 48. Write it out if you need to. You'll have a calculator on your final, so you'll be able to do 16 times 3 and figure it out. Now, you have a radical 3 waiting there. I'm going to use the property and split it up. Radical 16 times radical 3 plus radical 3. 16 comes out of jail. This is a perfect square. 1, 2, 3, 4. So you write a 4. Nothing else. Not radical 4. Not 4 times 4. You write 4. He comes out of the jail. Free him. So I have 4 radical 3s plus, here's a mistake, 1 radical 3. People will forget that there is a 1 there. And they won't add these up correctly. They'll just tell me that the answer is 4. But you have 4 radical 3s and 1 more radical 3. So this answer has to be 5 radical 3s. All right? So you split 48 with 16 and 3. 16 is a perfect square, comes out of jail as 4. You had 1 radical 3 waiting to be added together with him. So I add them up. And you get 5 radical 3. So the second example with the harder adding and subtracting. So 32 and 8 are different numbers. So I already told you, you can't add and subtract them unless they have the same number inside. Now you have to be very careful how you do this. I'm going to do this vertically, up and down. Doing this left and right is going to be a disaster. It's going to be very confusing. I'm going to start with 8, and I'm going to tell you why. 8 is a smaller number. It's easier for me to figure out how to split up 8. Like, I know that 8 is 4 times 2. I mean, I'm not stupid. So now what do? Well, I wrote 8 as radical 4 times radical 2. Radical 4 times radical 2 is radical 8. Notice that I skipped a step. I skipped this step. I don't have to write that step. If you want to, write that step, but you don't need to. All right, this is a step that you cannot skip this step. You must write this down. You can skip that one if you want to. So I skipped it here. Now, radical 4, this is a perfect square. 1, 2. He comes out of jail as a 2. Remember, this is a product. Put the little dot if it helps you remember. You have to multiply them. And then this radical 2, you're stuck with this. So the radical 4 comes out of jail, and I have minus 10 radical 2. I simplified this one first because it's easier. Now, I know that whatever I split this up as, it better have a 2. Because you might be thinking, oh, I know that 4 times 8 is 32, but that's the wrong pair. 4 times 8 is not going to work here. I needed 2. So you have to split up 32 using a 2. So just cut it in half. Half of 32, in case you can't figure it out, I'll teach you a little secret. You'll have a calculator. You won't need to do this, right? 32 is 30 plus 2. Half of 30 is 15. Half of 2 is 1. 15 and 1 is 16. So half of 32 is 16. That's a little bullshit. I don't have a calculator trick. So 32, I'm going to split up as 16 times 2. See? Same number. Same number. I need that number here, or I can't subtract them. Now, 16 is a perfect square. 1, 2, 3, 4. So take him out of jail as 4. Now he's going to hook up with his buddy 3 that's waiting for him, which gives me a 12. 12 what? 12 radical 2s. I have 12 radical 2s. I lose 10 radical 2s. 12 take away 10 is 2. The radical 2 has to stay the same. You keep the radical part. You add and subtract the numbers in front, and you keep the radical part the same. So 16 and 2, 4 and 2. So the radical parts are the same, so you can add and subtract them. You do not pick 4 and 8 here. All right? So that was the last adding and subtracting.